Hello everybody, welcome into another lesson. So today we are going to talk about solving logarithmic equations. So last lesson we solved exponential equations. Now we're going to do the inverse of that and solve logarithmic equations. Now for logarithmic functions, x does have a specified domain of all numbers greater than 0. So when we solve logarithmic equations, we have to check for extraneous solutions, which are basically any value of x that would cause an undefined expression, like the logarithm of 0 or a negative number. So let's look at what we have here. We have the natural log of 4x plus 1 equals the natural log of 2x plus 5. So the idea is, of course, we got to solve for x, but how are we going to do that? If we remember when we talked about logarithmic functions, to negate the logarithm, you have to raise both sides. You have to take the base and raise both sides to the power of that logarithm. So a natural log, remember, is a logarithm with base e. So if I take e to the power of the natural log of 4x plus 1, I'll have to do the same to the other side and take e to the power of the natural log of 2x plus 5. Doing so cancels out the logarithm, and now you just simply are going to have 4x plus 1 is equal to 2x plus 5. Which now you just go ahead and solve for x. This would give you 2x equals 4, which would give you x equals 2. But we have to check for extraneous solutions. So is this equation defined for x equals 2? Put it back into your original equation. If you put it on the left-hand side, you get the log of 4 times 2, which is 8 plus 1 is 9. So you get the natural log of 9 equals the natural log of 9, which both are positive numbers, both are defined, it checks out. So you would get the solution that x is equal to 2. Now, let's see here. Let's do some more. Log base 2 of x equals negative 1. So we have log base 2 of x equals negative 1. This is pretty much a dead giveaway because a logarithmic function, remember, this is like saying 2 to the negative first equals x, which simply means that x would equal 1/2. And if we put in the 1/2, the logarithmic function is defined at that point because it's greater than 0, so you'll get an x equals 1/2. That one was fairly easy. Alright, 4 times log base 3 of x equals 28. So we have 4 times log base 3 of x equals 28. Well, we just want to get that log base 3 of x by itself, right? So divide both sides by 4, you'll end up getting log base 3 of x is equal to 7, which now this is the same as saying that 3 to the 7 equals x. So let's just find out what the heck is 3 to the 7th. It's not going to be a pretty number. It's going to be pretty high up there. 3 to the 7th power is 2,187. So x would equal 2,187, which if you put in that value of x, it's greater than 0, so it is defined. So yes, this solution of x equals 2,187 actually does work. Alright, 16 times the natural log of x equals 30. Well, we want to get the natural log of x by itself, so divide both sides by 16. You'll get the natural log of x equals 30 divided by 16, which is simply 15 divided by 8, which, if you want to solve for x, you have to take e to the power of both sides. So this would be e to the natural log of x would equal e to the 15/8, which on the left side, the natural log is canceled out. You just get x equals e to the 15/8, which e to the 15/8 is greater than 0, so the function is defined there. So you would get x equals e to the 15/8 as your answer. All right, let's see. We have half of log base 6 of 16x is equal to 3. So we have half of log base 6 of 16x equals 3. Well, let's get that log base 6 of 16x by itself. So you would end up getting log base 6 of 16x equals 6. Well, this is the same as saying that 6 to the 6th equals 16x, which would end up giving you 16x equals, let's figure out what is 6 to the 6th power. $46,656. Now let's just solve for x, so divide both sides by 16, we should have an answer. You get 2,916. So x would have a value of 2,916, and if you put it into the logarithmic function, the value is definitely defined there because it's greater than 0. So x equals 2,916. All right. 1 minus 2 times the natural log of x equals -4. Well, we need to isolate that natural log of x term by itself. So to do that, you'll have 2 times the natural log of x would equal 5. Now let's get natural log of x by itself. So that'll be natural log of x equals 5/2. Then in order to get x by itself, we have to take e to the power of both sides. So take e to the natural log of x, that would equal e to the 5/2. Well, e to the natural log of x cancels out the logarithmic function. You'll just get x equals e to the 5/2. And if you put in e to the 5/2 for that x, it is defined there because e to the 5/2 is greater than 0. So x would equal e to the 5/2 would be your exact answer. All right. Good one. So we have 2 times the natural log of -x plus 7 equals 14. So 2 times the natural log of -x plus 7 equals 14. Well, let's get 2 times the natural log of -x by itself. So 2 times the natural log of -x would equal 7. Now get that natural log of -x by itself. You'll end up getting the natural log of -x equals 7/2. Now take e to the power of both sides to get that -x by itself. So e to the natural log of -x equals e to the 7/2. Alright, so now what you have is the log will cancel on the left-hand side. You'll have negative x equals e to the 7/2. Now to solve for x, you would get x equals negative of e to the 7/2. Well, here's the thing. Let's put in negative e to the 7/2 for our x. This would turn into the natural log of positive e to the 7/2. So actually the function is defined there. So x would equal the negative of e to the 7/2. This is where you really have to solve it out and put in that value of x into the original. If we had gotten that x equals positive e to the 7/2, we would have no solution because you couldn't have the log of a negative number. But of course the negative of a negative is a positive, so x equals negative e to the 7/2 actually does work. Alright. We have log base 5 of 2x plus 15 equals log base 5 of 3x. Alright, so log base 5 of 2x plus 15 equals log base 5 of 3x. So since we have the logs, we got to take that base 5 on both sides, raise it to the power of those logs. So 5 of log base 5 of 2x plus 15 equals 5 to the log base 5 of 3x. And so you have 5 to a log base 5 on both sides. The logs will cancel out. You'll just get your exponents. So you'll get 2x plus 15 equals 3x, which will literally just give you that x equals 15. Now let's put in this 15 into our logarithms on both sides. What's 2 times 15? That's 30 plus 15 is 45. So on the left side, it's defined. You get a positive logarithm. You get a positive number inside the log. What about the right side? 3 times 15 is also positive 45. So yes, the solution would in fact be that x equals 15. Alright, let's see here. So we have the ln of x plus the ln of x minus 2 equals 1. Now how the heck are we going to solve something like that? Excellent question. So what do we do here? Well, on the left side you have the sum of two logs. Isn't that the exact same as a product of these two terms in the log? So this would turn into the natural log of x times x minus 2 equals 1. Right? So now what we can do is take e to the power of both sides. You'll end up getting e to the natural log of x times x minus 2 equals e to the first, which the left side, the log will cancel out. You'll get x times x minus 2 equals e, which this will turn into a quadratic. You'll end up getting x squared minus 2x minus e is equal to 0. So you have a very hideous quadratic equation. I think we can solve this by completing the square instead of using the quadratic formula. So this will turn into x squared minus 2x plus 1 would equal e plus 1. Which would have to mean that x minus 1 squared equals e plus 1, which would give you that x minus 1 equals both plus and minus the square root of e plus 1, which would mean x would equal 1 plus and minus the square root of e plus 1. Now, here's where it's about to get very interesting. You actually have two solutions for x, but having said that, we need to take each solution and put these into our logs. So let's start when x equals 1 minus the square root of e plus 1. Okay? What do you get? What do you get here? So let's do this. Let's figure out the square root of e plus 1. That's about 1.928. Take 1 minus that, you'll get about negative 0.928. Well, here's the problem. Put that x value into your natural log. You got the natural log of a negative number. That's actually not going to work. So that x equals 1 minus the square root of e plus 1 does not work. That's an extraneous solution. Now what about when x equals 1 plus the square root of e plus 1? Okay? That would give you about 2.928. Alright. Well, we know it'll work for the first term. What about the second term? 2.928 minus 2 is 0.928. It's still defined. It would still be defined because you have a positive logarithm. So your solution, you have only one solution, is x would equal 1 plus the square root of e plus 1. So this is where you have to check for extraneous solutions. All right. Similar problem, we have the ln of x plus the ln of x plus 3 is equal to 1. So we have the ln of x plus the ln of x plus 3 equals 1. So the sum of two logs on the left, that's the same as taking the logarithm of the product of these two terms. So that'd be the logarithm of x times x plus 3 would equal 1. Now just take e to the power both sides. So you'd have e to the natural log of x times x plus 3 would equal e to the first, which the left side, your log cancels out. You'll literally get x times x plus 3 would equal e, which in short would give you x squared plus 3x equals e. Let's try to solve this by completing the square. So you'll end up getting x squared plus 3x plus 9/4 is equal to e plus 9/4. which would have to mean then that x plus 3/2 squared would equal e plus 9/4, right? So this would give you x plus 3/2 would equal both plus and minus the square root of e plus 9/4. So this is going to give you what looks like two solutions of x equals -3/2 plus and minus the square root of e plus 9/4. Alright, well, again, we're going to have to take some decimal approximations and really figure this out. Let's start with when x equals -3/2 minus the square root of e plus 9/4. Let's get a decimal approximation for that. So let's see. So you would end up with about -6.468. So go ahead and put that into your logarithms. It definitely doesn't work on the first term. You'd have the log of a negative number. And even if you add it to your second term, add 3 to it, you'd have -3.468, which still doesn't work. So this solution goes bye-bye. Now what about when we take x equals -3/2 plus the square root of e plus 9/4? What about that? Let's get a decimal approximation for that answer. You know what? I know what I did with the first one. Hold on, I forgot to take the square root. You can sometimes have that. Bottom line, please don't forget to take the square root of what you're doing. Don't forget to take the square root. Let's look at x equals -3/2 minus the square root of e plus 9/4. I entered e plus 9/4, I just forgot to take the square root of it, which is a big problem because that's going to yield a very different solution. Alright, let's see. Then alright, -3.729 is what you should get. Okay. Well, put that into both of your terms. You'd have the log of a negative number. Doesn't work. And then put it into your second term, you'd still have a log of a negative number. But if it even is undefined for one of the terms, it's undefined for the whole equation. So this still wouldn't work. But let's look at when x equals -3/2 plus the square root of e plus 9/4. So let's go ahead and do that. All right. You would get about 0.729. So put that 0.729 in for x. You got a log of a positive number. That works. And definitely positive for the second term. So Your only solution is that x equals negative 3/2 plus the square root of e plus 9/4. That would be the exact value of x. So yes, sometimes these equations can get messy, but this is why checking for extraneous solutions is extremely important. All right. We have log base 8 of 11 minus 6x is equal to log base 8 of 1 minus x. Alright, so log base 8 of 11 minus 6x equals log base 8 of 1 minus x. Well, the log is base 8, so we have to take 8 to the power of the log base 8 of both sides. So 8 log base 8 of 11 minus 6x would equal 8 to the log base 8 of 1 minus x, which on both sides the log will cancel out. Now you just have 11 minus 6x is equal to 1 minus x. Now just solve for x. You should literally get 5x equals 10, which would give you x equals 2. Alright, but let's check our work. Let's even put it on the right side. So if I put in x equals 2 on the right hand side, 1 minus 2 is negative 1. There's no power you can raise 8 or anything else to get a negative number. So really and truly, we have no solution to this. X equals 2 is an extraneous solution because you would get the log of a negative number. So truly, there's no solution to this problem. Alright, I have about 7 more. So let's see, 15 plus 2 log base 2 of x equals 31. Okay, so 15 plus 2 log base 2 of x equals 31. Well, let's get that log term by itself. So this is going to look like 2 log base 2 of x equals 16. Then to get the log base 2 of x by itself, we'll end up having log base 2 of x equals 8, which is the same as saying that 2 to the 8th power equals x, which let's now figure out what the heck that is. I believe 256, but let me make sure. Yeah, it is 256. Yep. So you get x would equal 256, and if you put in that 256, it's greater than 0, so the logarithmic function is defined there. So yes, x would have a value of 256. All right. Negative 5 plus 2 times the natural log of 3x equals 5. So we have negative 5 plus 2 times the natural log of 3x equals 5. Well, let's get that log of 3x term by itself. So this would turn into 2 times the natural log of 3x equals 10, which now let's get the log of 3x, natural log of 3x by itself. So that would turn into the natural log of 3x equals 5. And now we just got to raise e to the power of both sides to cancel out the log. So e to the natural log of 3x equals e to the fifth. The log cancels out on the left side. That would give you 3x equals e to the fifth, which then means that x equals e to the fifth divided by 3. And if you put that into your logarithmic function, you would actually end up then getting that a positive number for the logarithm, so that would totally work. So the solution is that x equals e to the fifth divided by 3. Log of 5 minus 3x equals the log of 4x minus 9. Alright, so we have the log of 5 minus 3x equals a log of 4x minus 9. Well, this is a common logarithm, meaning it's base 10. So we got to take 10 to the power of both sides. That would give you 10 to the log of 5 minus 3x would equal 10 to the power of log of 4x minus 9, which both sides of log cancels out now. You would end up with 5 minus 3x equals 4x minus 9. Now just go ahead and solve for x. You would literally end up then getting that 7x equals 14, which should give you an x value of 2. But let's check for extraneous solutions here. So put in on the left side that x value of 2. You would get 5 minus 6, right? Which is negative 1. You can't have the log of a negative number. It doesn't work. So truly, there's no solution to this problem. There is no solution to this problem because x equals 2 is an extraneous solution, so really no solution to this one. All right. 6.5 times log base 5 of 3x equals 20. Well, this will be a fun one. So 6.5 times log base 5 of 3x equals 20. Let's get that log base 5 of 3x by itself. So log base 5 of 3x is going to equal that 20 divided by 6.5, which is the same as 40 over 13. That's the exact same as 40 over 13. So now, to cancel out the log and get the 3x by itself, take 5 to the power of both sides. So 5 to the log base 5 of 3x is going to equal 5 to the 40/13. Well, on the left side, the log cancels. You would get 3x equals 5 to the 40/13, which would then give you that x equals 5 to the 40/13 divided by 3. Which, if we put this in to the original equation, you would get the log of a number greater than 0, so this does work. You just have a hideous solution of x equals 5 to the 40/13 power divided by 3. let's see. Natural log of x plus 5 plus, no, it's not plus, it's actually equals the natural log of x minus 1 minus the natural log of x plus 1. So we have a good one here. All three terms are natural logs. Well, look, let's just keep the left side the way it is for the time being. But what's true for the right-hand side? You have a difference of two logs, which follows the quotient rule. So this would be equal to the natural log of x minus 1 all over x plus 1. Right? Okay. So now we have it simplified. You just take e to the power of both sides to cancel out the log. So e to the natural log of x plus 5 would equal e to the natural log of x minus 1 over x plus 1, which the logs will cancel out. You're just now left with x plus 5 equals x minus 1 over x plus 1. Which that x plus 5 is the same as x plus 5 over 1, right? So we have a proportion. So we can cross multiply. This would then give you x plus 5 times x plus 1 equals x minus 1. So this would turn into x squared plus x plus 5x, so that's plus 6x plus 5 equals x minus 1. Which now we can simplify this. You'll get x squared plus 5x plus 6 equals 0. So we have a simple quadratic equation, which, how does that factor? This would factor into x plus 2 quantity times x plus 3 quantity is equal to 0. Alright, so let's go ahead and set each of these factors equal to 0. You would get x equals negative 2 and x equals negative 3. So let's put in negative 2. Well, let's hold it right there. If it doesn't work for even one of the terms, it doesn't work for the whole thing. So negative 2 minus 1 is what? That's negative 3. The log of a negative number doesn't work. So we got to discard negative 2. Alright, what about negative 3? Well, negative 3 minus 1 is negative 4. That also doesn't work. So we did all that work to find that there's really no solution to this. We actually have no solution to this problem since both of our solutions were extraneous solutions. So that's why it is so important to check your work. Alright, I got two more. We're almost there. Alright, so the ln of 5.6 minus x equals the ln of 18.4 minus 2.6x. Fun with decimals. Alright, so we have the ln of 5.6 minus x equals the ln of 18.4 minus 2.6x. Well, good news is they're both natural logs on both sides, so you're just going to take e to the power of both sides. So e to the natural log of 5.6 minus x would equal e to the natural log of 18.4 minus 2.6x, which now your logs cancel out. You're just left with the exponents. 5.6 minus x equals 18.4 minus 2.6x. All right, well, let's go ahead and solve for x here. So this would simplify into 1.6x. Let's figure out what the heck is 18.4 minus 5.6. That's 12.8. So you get 1.6x equals 1.28, which would give you that x would equal 1.28 divided by 1.6. Which would be the same as 128 over 160, because we want to try to get rid of that decimal. So what is 128 over 160? Well, let's see. It's not even going to be 1. But let's simplify this. Divide by 4, you get 32 over 40. Divide both by 8, you should end up simply getting 4/5. So you would end up getting x equals 4/5. Now, does this check out? On the left side, 4/5 we know is 0.8, so you would have a positive log. Now, what about the right-hand side? 2.6 times 4/5, that's not even 2.6. You would have the log of a positive number. So you would truly get that x equals 4/5. That would be your answer. Or 0.8, however you want to write it, but x equals 4/5. We have just one more. Final one. All right, 10 times the natural log of 100x minus 3 equals 117. So 10 times the natural log of 100x minus 3 equals 117. Well, let's get that logarithmic term by itself. So this will turn into 10 times the natural log of 100x would end up equaling 120. Now let's get the natural log of 100x by itself. So this would turn into the natural log of 100x would equal 12. So now we just take e to the power of both sides. So you would end up getting e to the natural log of 100x would equal e to the 12th. So the log cancels out. You just get 100x equals e to the 12th, which would then mean that x would equal e to the 12th divided by 100. And we know we're going to get a positive number, so this actually does work as our solution if we put it in. So the answer is x equals e to the 12th divided by 100. So that's it for this lesson. We got one more lesson left in the logarithmic functions unit, which the very next lesson will be about logistics growth functions. And then after that, we're going to move on to rational functions and their graphs. So I hope everyone has a great day. Take care.